My dear students, welcome back to our channel. In this video, I will be explaining the MBA second semester subject Total Quality Management. As prescribed by JNTUH and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 3 first important short question is: define Statistical Process Control, SPC. Statistical Process Control, SPC, is a method used to monitor and control a process using statistics. It helps ensure that the process operates efficiently, produces consistent quality, and reduces defects. SPC uses data from the production process to detect variations. There are two types of variations. 1. Common cause variation, natural, small variations in a process. 2. Special cause variation, unusual or unexpected changes that need correction. Tools used in SPC. Control charts track process performance over time. Histograms show frequency of defects or errors. Pareto analysis identify the most common problems. Example: in a bottling plant, SPC can monitor the amount of liquid filled in bottles. If some bottles are overfilled or underfilled, control charts help detect the problem early, so corrections can be made before large numbers of defective bottles are produced. Importance: ensures consistent product quality. Reduces wastage and costs. Helps in continuous process improvement. Easy way to remember. SPC is equal to using numbers to keep your process in control. Next important short question is: 2. What is the difference between chance cause and assignable cause in process control? Difference between chance cause and assignable cause. In statistical process control, SPC, variations in a process can happen due to different reasons. These are mainly of two types. 1. Chance cause, common cause. These are natural, random variations that are always present in a process. They are usually small and predictable. Example: in a sewing factory, slight differences in thread tension may cause tiny differences in stitching. This is normal and doesn't need special action. 2. Assignable cause, special cause. These are unusual variations caused by specific problems in the process. They are large and can be corrected. Example: if a sewing machine breaks or a worker uses the wrong needle, it leads to defective stitching. This needs immediate attention. Key difference table. Feature: chance cause, assignable cause. Nature: random, normal, specific, unusual. Size: small, large. Action: usually none, requires correction. Example: minor thread tension difference, broken machine part. Easy way to remember. Chance cause is equal to normal small bumps. Assignable cause is equal to big bumps you can fix. Next important short question is: 3. Write short notes on mean and standard deviation. 1. Mean, average. The mean is the central value of a set of numbers. It shows the typical value in a data set. Formula: mean, x, is equal to sum of all observations, number of observations. Example: marks of 5 students, 60, 70, 80, 90, 100. Mean is equal to 60 plus 70 plus 80 plus 90 plus 105 is equal to 80. 2. Standard deviation, SD. Standard deviation measures how much the data varies or spreads from the mean. A small SD means values are close to the mean. A large SD means values are spread out. Formula simplified. SD is equal to 11x to n. Example: using the marks above, SD tells how much individual marks differ from 80. Easy way to remember. Mean is equal to middle average. Standard deviation is equal to how far things are from the average. In SPC, mean and SD help monitor processes and check for variations, so quality can be maintained. Next important short question is 4. What is a Pareto chart? A Pareto chart is a bar graph that shows problems or causes in order of importance. It is based on the Pareto principle, 80-20th rule. 80% of problems come from 20% of causes. Purpose helps to focus on the most significant issues so quality can be improved efficiently. Structure 1. Vertical bars represent the frequency or impact of each problem. 2 bars are arranged in descending order, highest problem first. 3. Line graph shows the cumulative percentage of total problems. Example: in a factory, defects in a product. Scratches 40. Wrong size 30. Color mistake 15. Packaging 5. Pareto chart will show scratches and wrong size as most critical issues to fix first. Easy way to remember. Biggest problems first is equal to fix 80% of issues by addressing 20% of causes. In TQM, Pareto chart is used to identify priority areas for quality improvement and reduce defects efficiently. Next important short question is 5. Define process capability, CP and CPK. Definition: process capability measures how well a process can produce products within specified limits. It tells whether a process is capable of meeting customer requirements consistently. Key terms: 1. CP, Capability Index. Measures potential capability of a process if it is perfectly centered. Formula: CP is equal to USL LSL 6 sigma. USL is equal to upper specification limit, LSL is equal to lower specification limit, sigma is equal to standard deviation. 2. CPK, Capability Performance Index. Measures actual performance considering process centering. Formula: CPK is equal to min USL mu 3 sigma mu LSL 3 sigma. Mu is equal to process mean. Example: a bottle filling machine should fill 500 plus or minus 10 milliliters. If most bottles are filled between 495 to 505 ml consistently, CP shows machine's ability to meet plus or minus 10 ml. CPK shows actual performance considering if machine is slightly off-center. Easy way to remember. CP is equal to potential, how good it can be. CPK is equal to actual, how good it is now. In TQM, high CP and CPK values mean high quality, less defects, and satisfied customers. Next unit 3. Long questions. First important long question is 1. Explain the 7 basic quality control tools with suitable examples. 7 basic quality control (QC) tools. The 7 QC tools are simple but powerful techniques used in total quality management (TQM) to analyze and improve quality in processes. They help identify problems, monitor processes, and prevent defects. 1. Cause and effect diagram, Ishikawa or fishbone diagram. Purpose: find the root causes of a problem. Example: if a bottling machine produces underfilled bottles, causes may be machine settings, human error, or material quality. 2. Check sheet. Purpose: collect and organize data systematically. Example: count the number of defective bottles per day on a simple table. 3. Control chart. Purpose: monitor process performance over time to detect variations. Example: Track daily production of bottles to see if they stay within 495 to 505 ml. 4. Histogram. Purpose: show frequency distribution of data visually. Example: plot how many bottles were filled at 495, 496, 497 milliliters, etc. to see the distribution. 5. Pareto chart. Purpose: identify the most significant problems using the 80-20th rule. Example: most defects in bottles come from cap sealing issues, 80%, less from label misalignment, 20%. 6. Scatter diagram. Purpose: show relationship between two variables. Example: compare machine speed versus number of underfilled bottles to see if faster speed increases defects. 7. Flowchart, process map. Purpose: visualize the steps in a process to find problem areas. Example: map the bottle filling process, bottle loading, filling, capping, labeling, packing. Easy way to remember. Fishy cats hate happy small funny pups. Fishbone, check sheet, histogram, flowchart can replace 1H, scatter, Pareto, flowchart. These tools are simple, do not require advanced statistics, and help solve quality problems effectively. Importance. Using these tools, companies can reduce defects, improve customer satisfaction, and save costs, forming the foundation of continuous quality improvement in TQM. Next important long question is: 2. Describe control charts for variables and explain their types. Control charts for variables and their types. Control charts are graphs used in statistical process control, SPC, to check if a process is working correctly or if it has unusual variations. When we measure numerical data, variables, like weight, length, temperature, or time, we use control charts for variables. These charts show whether a process is stable, in control, or needs improvement. Think of it like a health checkup. Just like doctors track your blood pressure to see if it's normal, businesses use control charts to check if their product quality is within limits. Types of control charts for variables. 1. X bar chart. Purpose: tracks the average of a sample over time. Example: measure the average weight of 5 packets of sugar every hour. If the average stays near the target, the process is in control. 2R range chart. Purpose: shows the variation range within a sample. Example: if some sugar packets in the same sample are much heavier or lighter, the R chart will show this variation. 3S standard deviation chart. Purpose: similar to our chart but uses standard deviation to measure variation. Example: used when sample sizes are larger, more than 10 units per sample. How they work. The chart has a center line, CL, upper control limit, UCL, and lower control limit, LCL. If data points fall inside these limits, process is stable. If points go outside, process needs attention. Why important? Helps detect problems early before products reach customers. Saves time, cost, and improves quality. Easy memory trick. X for average, R for range, S for standard deviation. X plus R are most common and used in industries like food packing, electronics, or automobile manufacturing. Next important long question is: 3. Discuss process capability analysis and how CP and CPK are calculated and interpreted. Process capability analysis, CP and CPK. Process capability analysis is a method used to check how well a process can produce products within required limits. Every product has specification limits, maximum and minimum allowed size, weight, etc. If the process consistently makes items within these limits, it is called a capable process. Think of it like filling water bottles. If a 1-liter bottle is always filled between 0.98 liter and 1.02 liter, your process is capable. If some bottles are overfilled or underfilled, it is not capable. Key terms. 1. USL, upper specification limit highest acceptable value. 2. LSL, lower specification limit lowest acceptable value. 3. Sigma, sigma standard deviation, shows process variation. 4. Mu, mu process mean or average. 1. CP process capability index. CP measures potential capability, ignores process centering. CP is equal to USL, LSL 6 sigma. If CP greater than or equal to 1, the process variation fits within limits. Example, if spec limits are 10 plus or minus 3, 7 to 13, and 6 sigma is equal to 6. CP is equal to 13.76 is equal to 6 divided by 6 equals 1. Process is capable but not checked for centering. 2. CPK process capability performance index. CPK checks how well the process is centered. CPK is equal to min, USL mu 3 sigma, mu LSL 3 sigma. If CPK CP, process is not centered. Higher CPK means better and safer production. Interpretation table. Value meaning. CPK 1 not capable, many defects. CPK is equal to 1 meets specs, borderline. CPK greater than or equal to 1.33 good capability. CPK greater than or equal to 2 excellent, 6 sigma level. Why important? Helps reduce defects. Improves customer satisfaction. Guides process improvement in manufacturing, packaging, etc. Easy memory tip. CP is equal to can it fit? Variation check. CPK is equal to centered or not. Center check. Next important long question is 4. Explain statistical fundamentals and their importance in total quality management. Statistical fundamentals and their importance in TQM. Statistical fundamentals are the basic concepts of statistics that help in collecting, analyzing, and interpreting data to make decisions. In total quality management, TQM, they are essential for improving quality and reducing defects. Instead of guessing, companies use numbers and data to understand problems. This makes decisions scientific and reliable. Key statistical fundamentals. 1. Data types. Qualitative data, non-numerical, like good or bad. Quantitative data, numerical values, like size, weight, time. Example, in a biscuit factory, biscuit taste is qualitative, while biscuit weight is quantitative. 2. Mean, average. The sum of all values divided by the number of items. Example, if biscuit weights are 98g, 100g, and 102g. Mean is equal to 98 plus 100 plus 102, 3 is equal to 100g. 3. Median. The middle value when data is arranged in order. Useful when there are extreme values. 4. Mode. The value that appears most often. Example, if most biscuits weigh 100g, mode is equal to 100g. 5. Standard deviation, sigma. Measures variation. Low sigma means consistent quality, high sigma means inconsistency. 6. Range. Difference between the highest and lowest values. Importance in TQM. Detect problems early. By analyzing trends and variations, companies can spot quality issues before they get worse. control processes, control charts and histograms help monitor production. Make decisions based on facts, reduces guesswork and emotions in decision-making. Continuous improvement, statistical data shows where improvements are needed. Customer satisfaction, consistent quality leads to happy customers. Example. In a pen manufacturing company, if the target pen length is 14 centimeters, statistics help check if all pens are close to 14 centimeters. If some pens are 13 centimeters or 15 centimeters, analysis reveals where the problem is in the process. Easy memory tip. Statistics is equal to numbers tell the truth. TQM uses these numbers to plan, check, and improve quality step by step. Next important long question is 5. Illustrate the use of cause and effect, Ishikawa, diagram in identifying quality problems. Cause and effect, Ishikawa, diagram in identifying quality problems. The cause and effect diagram, also called the Ishikawa diagram or fishbone diagram, is a tool used in total quality management, TQM, to find the root causes of a problem. It looks like a fish skeleton, where the head represents the problem, effect, and the bones show possible causes. This diagram helps teams visualize all possible reasons for a quality issue and focus on solving the main cause instead of just symptoms. How it works. 1. Write the problem at the head of the fish. 2. Draw the bones for main categories of causes. 3. Brainstorm reasons under each category. 4. Analyze which causes are critical and take action. Common categories of causes, 6 Ms. Man, worker skills, training, fatigue. Machine, equipment problems, maintenance issues. Material, quality of raw materials. Method. Poor work process or procedure. Measurement, errors in measuring tools or techniques. Mother nature, environment, weather, temperature, lighting, etc. Example. In a biscuit factory, biscuits are breaking easily during packing. Man, workers handle biscuits roughly. Machine, conveyor belt speed too high. Material, weak packaging material. Method, wrong stacking technique. Measurement, no regular check on biscuit weight. Environment, humidity makes biscuits soft. By studying this diagram, the company finds the main issue is poor packaging material and fixes it. Why it's important? Makes complex problems easy to analyze. Encourages teamwork and brainstorming. Identifies root causes instead of treating symptoms. Saves time and money by targeting the real issue. Easy memory tip. Think of a fish. Head is equal to problem. Bones is equal to possible causes. Solving the problem is like removing the bad bone that hurts quality.